Before we start analyzing circuits with Laplace, let's just go over a flow diagram that will help us understand where we place all these techniques that we're going to learn. Typically, you have a linear circuit, and what we have been doing is we extract the differential equation out of this linear circuit, and we apply classical techniques to find the solutions for that differential equation so we can find the response in time. And that response, or the waveform that you get in time, typically if it's a homogeneous or a natural response, you get a graph for these one like for first order equations, or for second order something like this. Or if the input is a step function and you have a forced response, then you get these for the first order circuits and these one for the second order circuit. Well, but we are still doing all these in the time domain. But sometimes circuits are a little bit more complicated and they might have a higher order than a second order. And how do we actually get an answer out of this differential equation? We might struggle with that. So Laplace comes into our rescue, where we're going to actually switch domains. We're going to the Laplace domain, but the goal is to go from this linear circuit and somehow get to this response waveform. And there are mainly two ways of achieving that. The first one, the path number one, consists of applying the Laplace transform to your linear circuit, and you have what it's called a transformed circuit. Then from here you extract your algebraic equation out of that circuit. You're going to massage that equation with a set of techniques, so you prepare that equation to be in this response transform, and then I can apply the inverse Laplace to that response transform so I can get my response in time. Notice that everything that we're doing here on the right side is in a new domain that we call the Laplace or the S domain. The path number two is sometimes you can actually take the differential equation out of your linear circuit, and if that happens, then you can apply a Laplace transform on that differential equation and get right away the algebraic equation. So you end up at the same spot as you were before, but now you can just go directly and massage those equations, get into that response transform in the S domain, and then apply the inverse Laplace so you can get the waveform. So what it's important to have in mind is this flow diagram that you have over here, and as we go through the next set of videos, I'm going to place the techniques throughout this flow diagram so you don't get lost and you know where each technique is in this flow diagram.